Hi, welcome back to another lesson on our backend PHP. On this lesson, we are going to discuss database. Database. Database can be referred to as a container where we store our data. And this data has to be in tabular form, depending on the database. So in this case, we're going to look at some different types of database that we have. We have different database softwares, which are Oracle database, MySQL from Oracle. We have SQL Server from Microsoft. We have even Microsoft Access is a database. We have MongoDB. We have Redis. We have Sybase, Terabase, Teradata. We have DB2 from IBM, and a lot more. But in this class, we are going to look at MySQL database because it is the one that we have inside our WAMP or XAMPP server simulator, but they have similar behavior. They all have one language that we use to communicate with them, almost all of them, which is what is called SQL. SQL, except on databases like MongoDB that we use JSON to communicate with. That it collects our data in JSON format or any other format, but not in SQL. So SQL simply means structured query language. It's a standard programming language that is used to manage relational databases and perform various operations on the data in them. Okay, so this SQL, we now have different types of SQL statements. As it is mentioned that it is a programming language on its own, but it looks like English. In fact, it was formerly called Structured English Query Language before it was finally named to be Structured Query Language because it is English alike. So this language is used to communicate to almost all the databases except in some exceptions of NoSQL database such as MongoDB and the likes. So today we want to look at some of these types of SQL statements that we have. We have what is called DML. Let me type inside my let me just type it here. We have DML. DML simply means data manipulation language, where we have statements like select, insert, you can see, delete and update. These are DML statements. We have DDL, that one was for data manipulation language. DDL, we have DDL, which is called data definition language. This is where we have create table, create, we have create, we have alter to change something in the table after creating it. We have drop to drop a table. We have truncate. To truncate means that you want to reset a table back to the beginning. is quite different from delete. Delete will only delete the record inside. Truncate will reset the entire table to default. In delete, if database is automatically generating a number ID, it won't start from the beginning again with that number. It will continue where it stopped. Let's say, for instance, you have 100 records and the last ID was 100, and then you delete all the 100 records. That's for delete. If you insert a new one, it will start from 101. But when you truncate, it starts from 1. You start from 1. That's the difference between delete and truncate. So you truncate, and do some other ones. We have, let me just mention the ones that are useful for us in this course. So we have rename, okay, and then we have comment. I think that's all on DDL. We have DCL. DCL means data control language. Data control language, you use this one to control access to objects in the database, such as grant and revoke. You can grant access to a table, you can revoke access to that table. You can grant maybe select only on the table. If you decide, you may grant insert, update, and all that on the table. So depending on whatever. So we use these ones to control access, data control language. Then we have TCL, transaction control language. Transaction, this one is transaction based. Here we have commit. When you want to make a change to be permanent, commit. Rollback, to roll back a change to the former state. And then save point, to create a marker. To create a marker, just like we create a restore point on our system. Like, okay, everything is fine here. This is a restore point. Whenever there is problem after this, I can always come back to this state and maintain my default restore point. So that is all that. But for the purpose of this class, we are only actually concerned much more that will be interacting and used every day in our application is the first one and then part of the second one. Alright, so let's look at this from the database. How do you access database in your WAMP or XAMPP? You go to localhost / PHP MyAdmin. This will take you into the server where you'll be able to access the database. You know, I told you when we were installing this that we have in WAMP. WAMP is for Windows. It has Apache. It has MySQL. And it has PHP. So now we want to access the PHP MyAdmin. It is like an administrative tools in WAMP or XAMPP. So username is root. I don't have password. It's empty when I was creating this. Click on go. Then I'm accessing MySQL. When you install this, you know, if you take note, you install two databases. We have MySQL and MariaDB. But I am installing, I'm connecting to MySQL. If you are using XAMPP, you may not have this experience. Once you just type localhost/phpMyAdmin, it will just log you in directly if you have not created password and all that. So here, this is the interface. We have the server. This is server. We have connected to the server with a port 3306 MySQL server. Databases. We click on this. You see a list of databases that you have created before, but if it is new, you only have like 3 or 4 that come with the WAMP or XAMPP. So if I need to create a database, let's say for instance, I'm creating a database and give it test1. That's the name of my database. This one, the collection is like a language character set. We can just pick UTF-8 general CI. Here it is. And then we'll click on create. Yeah, database created. And then if you look at it, we are now, formerly we are inside the server, now we are inside the database we just created, test1. So there is no table, and remember I told you that our data is going to be stored in tabular formats. So we need to create a table at least to start with. So we'll go on and give our table a name. Let's say we're creating users, for instance. And then for now, we'll now look at, okay, how many columns do we need for this table? At least a table user that's going to store users' information. We're going to have at least first name, last name, username, email. At least let's start with that. So that's 4. And then there will be ID, making it to be 5. So I will explain what ID is later on. So we give it name, users, and column 5. So we are starting with column 5. We can always edit that. We can always add more columns as we want to at any time. It is not a permanent thing. We are just giving that to know how many columns this guy should create initially for us to add our records. So here I'm going to say ID is the first one. The second one will be first name. This will be last name. This will be username. And this will be email. Okay. Now, data type. As we mentioned in PHP, the data type is the one that determines the type of data a field will accept. So in database, it's also applicable. We define a data type for each column on our table, so that the type of record we are going to be sending and store in this table for each column will be determined. Taking for instance, a column that you specify to be integer will not accept text from you. So here you have to define strictly your data type. Now ID is always in number type. So we have different types of data type. They are grouped here. Date, these are just frequently used ones. Int, variable, character, text. So we have date and time. We have a lot of them, strings types. We have special types and JSON format type. So MySQL also supports JSON, like MongoDB and all that. So now we have integer. That is, if you place your mouse on it like this, you will see what it means. It's a 4-byte integer signed. Range is what? -2 billion to +2 million. 2 million. So this one is a text format. Why? We have variable character that takes both variable and character combination. Text, we also take variable and character combination. We have small integers. This one has a minimum number from -128 to +127. Small integer, we have more than that, 32,000. We have medium integer that takes more than that, and then we have integer that takes 2 billion. We have big integer. that takes more than that, 9 billion. We have decimals, we have floats, double, real. These are decimal family. They have decimals. We have bit, we have boolean, we have serial. We have date and time, string. We have talked about variable, character. We have character if you don't want to use combination of variable and character. We have the one for binary. We have the one for big large objects, such as you want to store images, media files like audio, video, documents like Notepad, Microsoft Word, and all that, to use block. Enum and sense special for geometrics and all that, and then JSON. It depends on the type of data you want to store. But in this case of our ID is always a number format. We leave it as integer. Now, what's the length of integer we want it to be? I will say 11. 11 simply means 11 digits, not like 1 to 11. 11 digits, that's the length. Then for our first name will always be in form of text and all that, so that's variable character. And most of the time, you specify the length and make sure you specify the accurate one. Usually name is no more than 25 characters except some special countries. Then this one too, 25 characters. Username, because people can choose anything as their username, we may need to increase that to maybe 45. By the time they type 45 characters, at least the person is okay. Email may be longer, say this one is 255 and all that. And then what happens to default value? Default means while after creating this table, when you want to add data into the columns, if it does not specify record for a particular column, you can put a default value here that will be what will be the value of that column if you did not specify value for it. Collation, well, as we discussed when we are creating the database, it is actually optional. You may leave the collation for now. Then attributes, whether it is binary, it is signed or unsigned, or on update and all that. Then we have null. You check these check boxes, whether the column should accept null value or it should not accept null value. If you leave it unchecked, that means it is compulsory, it is required. I know you must have been seeing this when you are filling forms. On the form, they will put asterisk star red with red color on some fields, while they will tell you that some fields are optional. Yes, that is what we are declaring here in the database level. Here we have, if you leave it unchecked, that means all the fields are required. But maybe for instance, you check this, that means it is nullable. It can be null. If they did not provide value yet, it will be null. It will take it and add null to that column. But you may specify a default value. Okay, when they did not specify record, then use this as a default value. Alright, so now we have index here for our ID column, ID that is integer. We'll give it an index. This is a constraint. We have what is called primary key, we have unique key, we have foreign key, and all that, check constraints and everything like that. Primary key, what's a primary key? A primary key is a column that uniquely identify a record. It uniquely identify a record. Taking for instance, we are creating a table and we specify first name, last name, username, email. In this case, we might have two users with the same first name, last name, the same age, even they might want to use a single email because they bear the same name and everything, but the ID will differentiate them. Taking for instance, when you were in school, maybe your name is Johnson, and in that school you have a lot of Johnsons, that you even have the same first name, last name, the same age and all that. What will differentiate your own Johnson from other Johnsons? It is your matric number. That means your matric number is a primary key whenever they are entering record for you in that school. Nobody must have the same matric number with you, because that is what uniquely identifies you as a student. Your name cannot identify you, because they will have a lot of people bearing the same name as you, even have the same information as you. Your bank account number is a primary key, because that number will only be assigned to you only, not any other person. So in this case, we have unique key. Our primary key, we have not null. Any column with primary key must not accept null value, and it will have unique constraints, and it must also be unique. No other record in that table will have whatever the primary key value is. Taking for instance, if you make first name to be primary key, that means when you enter someone with name Johnson, no other Johnson can come into that table again. That's the purpose. It may not be null, it must not be null, and it must be unique. But for unique, the same way, unique is the one that actually make a column to be unique. It won't have duplicate records, but primary key combines both not null and unique constraint together. So we are going to give our ID primary key, give it primary key, and then we have auto increment. Auto increment is a situation whereby the ID column, is an ID. Maybe you enter the first record, you make the ID to be 1. You enter the second record, you make the ID to be 2, and you add on and on like that up till you get to late point. Probably when you are done for that day, you leave it and go. You come back next day, you want to continue with your record, and you've forgotten the last ID you used. So in this case, you allow the database to be the one generating the number automatically. That is what auto increment is all about, so that you won't have to start stressing yourself. In fact, whenever you are entering record on this table, you don't need to provide value for the ID, because it is now being handled by the database. It will be auto incrementing it. You can put a comment to add comment like, okay, this what the column is all about is like is the primary key of the table and all that. Virtuality, you can make it a virtual or stored. You can move the column to like down, up, or anywhere. So that is that on this. So now we have our others, but we want to make our email to be unique, so that two people will not have the same email, but yet it allows no value. That is what a primary key will not take. Primary key will not allow you to have a null value and make it primary key. It won't allow you. But a unique key can still be null, but that is, it can be null. But whenever you are providing value, whatever you are providing must be unique. It must not exist in the database already. So after doing this, then we can change our storage engine to InnoDB. When I'm using my SAM, so that in case we want to relay this table with another table within the database. So I think with this we are good to go. If you need more columns, you see add one column here or two, you can increase the number and click on go. But even after creation, we can still add more columns. So let us create our table. So here you can preview the SQL this guy want to run for you. You can see it's using a create statement. That is a DDL, create table, then the name of the table, the column specifications and all that. and then storage engine. So if you close it, we can now save our table to execute the statement, whichever one. Okay, so this creates our table. Yeah, we have the table now, users. Don't forget, we are still inside the SQL server, the database text one. Now we have now switched to table users. You need to be aware of this so that you won't put your data in the wrong table. Okay, so our table has been created. So under structure, we'll see the structure of the one we have defined when we are creating the table, like the column names, the data type, the collation, the null, whether it is null or not, whether it allows us or not, whether we have default value, whether it is has comments, whether it is auto increment or other things. We can change for each column here, or we can select everything at once and then change all of them at once. We can make a column to have any of these constraints. If you like, we can drop a column or drop the entire table. So we can add more columns. See, this is what I'm saying now, that in case you want to add, you can add maybe 1, 2, 3 or 10 columns. Then you specify where you want it to be, maybe after this email or before the email, or maybe before any of this or after any of these columns. Then you click on go. So let's say, for instance, I want to create one more after email. If I click on this, then it gives me that. So let's say I want to have created date, that is a date that the record is created. So this one will be in form of timestamp, so that to take the time as current time and milliseconds with it. Now default, we are not the one that will also be typing something here. We want to give it a default that anytime we insert a record, we won't provide date ourselves. You just get the current date. You say current timestamp, get the current date, and then we save. If you want to see what you are running, the SQL statement, you can see this is alter. It's also a DDL. Alter table users, add created date, and data type is timestamp. It is not null. It shouldn't be null because we didn't check this. And then we are having a default of what? Current timestamp. This is a function that we get the current time after email column. So we can close that and create the column. Then our column is created. So we go back to the structure to see. See, this is our table now. We now have the new column added. If you want to see what is inside your table, you can go to browse and then you'll see what is inside your table. For now, there is no record inside your table, and you can see it's giving you the statement is running, which is what? Select star from users. What is star? Star means all. So we can run this query ourselves inside this SQL, because actually this is a testing environment. Will be the one where we are developing our application to be running these queries. So this is the query we are supposed to run ourselves. Select all. We don't need the dark code. Select star from, star means all in database. So from users. So if we do this and run it, we get that same thing that we got the other time. That's it. No record for now. Now let us go ahead and edit this query, change it to insert, and we use that to insert a record. How do we insert record? The syntax is insert into then the name of our table. In this case, it is users. Now after that, you specify the columns you want to enter value into. You remember that in our table we have, this is the database here, text 1, and then right inside we have the users table. If you want to create a new user, you click on this new and it gives you to create another table. But now what we want to do is we want to insert into these users. We want to insert record into these users. So I will insert into users. Remember, we are inside the database. Insert into users. So I provide the columns I want to insert because it's not all the columns. In the users table, we have ID, first name, last name, username, email, created. But remember I told you that ID and created, we have given it to the database to handle for us. So we only need to do what? Add record into first name, last name, username, and email. So those are the things we type right here. See, first name, comma, last name, comma, username, comma, then email. The last one we won't put comma because that's the end of the columns. Those are the columns we want to add record into. Then values. Values. What are the values that we now want to insert into each of these columns? There is something in database. Whenever you are inserting a text that is not number, a text, you have to put it in single quotes. Just like in PHP, a string must be in double quote or single quote. So in database, it must be in single quotes. So single quotes, that is, I don't know what we call that, 1 single 1. This is it. This is one quote. Then we close the quote, single. Okay, so maybe for this one is John, first name, comma, that's the first name. Another one, last name, Wales, comma, username, in quotes, maybe J Wales, then email, maybe jwales at gmail.com. Remember the quotes, no mistake, don't forget about that. Then those are the values we want to insert into our table. Then we go on and run it to see what happens. You can see one row inserted. We have been able to insert one row into our table. If you want to insert more, we can have multiple insert statements at a time. Let me copy this and duplicate it. Okay, let me edit so that I'll be able to copy. Can have multiple insert at a time into the database. So I will change this one to, so you have to terminate each statement. The reason why we don't need to terminate that one when it was just one is that there's a termination here by default, but because we are running multiple now, we have to terminate each statement. So maybe this one is no more Johnson, is now James. James Y. J1 at Gmail. Jane. Watson. C. G. W. Then Jane Watson at gmail.com. Here, remember that our email is unique. If we use an email that already exists, it will complain. Let me try it. Even if I change John, the name, to Jack Bauer, J Bauer, and then the email that we have already, which is jwales. Now if I run this one, see we have error, and it's pointing to that particular statement that returned the error, which is what? jwales at gmail. So in that case, you cannot insert a record of what you have before. So that means we need to adjust that. I will just need this one to be unique by adding something to it. So if I run now, then we have those ones that we insert the other time has been inserted. We are supposed to remove them, all these ones. So the whole records is already there now. We don't have to do this again. If you do it again, all the records will duplicate, and then the email will only be the thing that will not be duplicated. So if you go to browse, we'll see all our records. See, we have John, James, and Jane. Okay, so we didn't insert that Jack because it was having the same email with John. Okay, so that is how we insert record into the system. We now have record. You can see our ID is populated by default. Our created date is also populated by default, and as at the time we are inserting those records. Now let us now start selecting from our table. We go to SQL. Remember, we are still here. The database is test1. So I will do a select all from users. If I click on go, then I get all the records. Now in database, you select all, select star, select everything, but we may decide to select certain columns, not all the columns. That is limiting rows that is returned. Limiting columns that is returned. Maybe I only want to see, I don't want to see the ID. I have no business with that. I don't want to see the created date. I have no business with that. I only want to see username and email. I don't even bother about his first name or last name, but username and email. You specify that here rather than star. So select username, comma, email. So the last one won't have comma. Select username, comma, email from users. That is the table. Then we get only that, username and email. That is it. We have only the username and email. Now, but it's still selecting for all the records in the table. If you now want to limit rows, because that one was just to limit number of columns. You want to limit rows, that is when you will use, it's in different forms. We can use limits. If I say limit to 1, that is I only want to see one record, one row, and that's it. I only get the first record because it will always be just the first ones. If you increase it to be 2, it will pick the first 2 from the table. But if you want to see the record of a particular person, then you will use where condition. Where condition. Here, for instance, where first name equal to, now the name I want to access is a text. I have to put it in quote and type it exactly the way it was entered. See, Johnson for instance. I don't know whether we have Johnson. Where first name equals to Johnson, we don't have anyone with Johnson name. Well, let me try John. Yes, we have someone with John name, first name of John, and his username is jwills and email is jwills@gmail.com. So we've selected 2 columns and just one record, the record of a particular person. Yes, it may not be too good to say where first name is equal to John. If you have 2 people that BS John, is going to return the 2 of them. If you have 100 people with John name, it will return all of them. So it would be good if we use what ID that separates all of them from each other, if truly we want to get one record of a particular person, the record of a particular person. Okay, so that's how to select limiting rows and all that. Now if you want to do a search, let's say we want to look for people whose name has J in it, whether it starts with J or it ends with J or J is in between, then we'll be using something like where first name like, then here we will put percentage here, that is search leftward and then search right outward. So when we click on this, it will bring all of them who has first J in their name. Anyone that has J in his name is going to be returned. So that is how we do like. This one is used in the case of like maybe you want to do a search. Like okay, they want to search for a record. As they are typing it is searching, then you use something like this so that it will look for anyone who has that particular character in their record by searching. What I'm saying is it's good for it, but it's not only for searching that it is used for. Then let's assume that we want to use number. If you want to use number, let's say age or something like that, then you may not necessarily need to quote it. It might be equal to, there may be 12, maybe age is what you want to use. For instance, if you want to use ID, you know ID is an integer. Say ID equal to 2. Anyone with ID of 2 will come out in this case. And that's it. That's it. ID of 2. Okay. Now, you can order the way your record comes out. Let's say I don't want to use where condition. I want to return everybody. Select email, blah 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 from users. Order by ID. You know, it is ordering it automatically for us in ascending order. That is why if we run this one will still do that ascending order. It's returning it according to the ID, which is 1, 2, 3. If we go ahead and check, you will see what I'm saying. Let's say we have ID as part of what we are selecting. If I do this, see the ID is being ordered ascendingly automatically, even whether we put order by or not. So if I now say okay, I want it to be in descending order, desk, descending order, then we go on and then we get it in descending order. So we can use any column, we can use ID, we can use first name, last name, username, or email. We can use anyone as our order by description. So that we here we're going to move on to another type of SQL. We have used insert, we have used select, you have seen create. Now let us look at update and delete. How do you update a record? How do you delete a record? To update a record, remember I said ID is the only thing that is unique. Now let's see the syntax to update a record. If I should go on and say update what? The table, users. Now set, maybe for instance, column 1 is equal to blah blah, comma, column 2 is equal to blah blah, comma, on and on and on to column n, the last column is equal to blah blah. That's how you update a record. But in case if you are not updating every column, you only want to update a column, then you stop at the ones that you only want to update. Maybe the first column you specify here only. Taking for instance last name. So if I say set last name is equal to ncnv. If I should run this statement like this, it will affect all the records in our database because you did not specify whose record to update. You are only saying set the last name to be this, and it's going to affect all the records in the database. So therefore, for that not to happen, we will say where id is equal to 2, for instance, and then we run it, and then it says one row affected. If you now go ahead and check, go to browse and check, you can see that the one with id of 2 has his last name changed to ncnv. That is how to update. If you now want to delete a record, don't forget we are seeing inside the database here. To delete a record, you say delete from, this one is in two ways. Delete from users, where, don't forget the where id is equal to 2. This is it. If you don't want to say delete from users, you can just say delete users, but that one looks scary. It looks like you want to delete the table itself, but when you say from, that makes it to be more friendly than saying delete users. So if we run this now, see, and then say one row affected. If you go to browse now to see, we have only 2 records. That particular one has been deleted. So this is how we perform database operations in our application. We have seen how to select, we've seen how to update, how to insert, and how to delete. So this is where we are going to be stuck. Thank you.